Achieving optimum tire wear is the goal of all truck operators. A critical step in doing this is making sure that the truck is going straight down the road with all axles aligned and all suspension and steering components operating properly. The Michelin Attack Plus video shows the steps necessary to ensure that optimum tire wear is achieved through proper alignment and maintenance. These steps include verifying axle parallelism, ensuring correct axle thrust angles, setting correct toe in, verifying correct Ackerman or toe out on turns. Additionally, proper identification of worn parts will help ensure a better utilization of labor, and the user saves as a result. These steps provide a quick, low-cost, yet effective method of determining whether a poor alignment condition exists. It is not intended to replace a full all-wheel alignment that can be done by a competent alignment technician with a properly calibrated alignment system. The techniques that will be discussed in the following segments are simple yet effective and utilize a minimum of equipment. Most of these items are readily available at any hardware or home center. These items include a chalk line without chalk added, a small tape measure with metal or mylar tape graduated in millimeters, a flashlight, a toe scribe, a homemade version will suffice, 2 cans of white spray paint, large plastic bags, a jack capable of lifting the front end of a tractor, a T45A heavy-duty tire iron. The starting point of all vehicle checks is to set it up correctly. The best way to check the truck is with it on a smooth, level surface. Avoid areas where one or more axle ends are located in a floor drain or similar depression protrusion. The vehicle should be driven into the inspection area in a straight line, at least 2 to 3 vehicle lengths, to ensure that the axles are in their normal straight-ahead position. Care should be exercised when bringing the vehicle to a stop. Let it slow to a stop instead of hitting the brakes, as this could affect axle positions. Securely chock the vehicle to prevent unwanted movement. Record vehicle information such as vehicle number, VIN, odometer or hubometer reading, tire air pressures, and tire tread depth and wear patterns for all tires. When measuring tread depth, avoid the tread wear indicators. We are now ready to start checking the truck's alignment. Ensure that the front tires are steered straight ahead by measuring the distance between the inside rim flange and the leaf spring on both left and right sides of the vehicle. These distances will be equal on both sides when the tires are steered straight ahead. Mark a reference line on the steering wheel and steering column with chalk for future reference. In order to determine if the steer axle is skewed, measure the distance from the spring pin perch or bolt to the U-bolt on the front axle. Repeat this measurement on the other side of the vehicle and record the results. The next step is determine if the tandem axles are offset from the frame any significant amount. This is done by measuring the distance from the frame rail to the rim flange at each end of the axle. Making this measurement off the inside of the frame rail provides a more precise reference point. Record these offset values for later use. At the same time as the above measurements are being made, visually check the vehicle for anything that may indicate problems with the steering or suspension system, such as kingpins, tie rod ends, steering stops. Ensure that steering stops are in place on both sides. Leaking shock absorbers. Checking ride height. See manufacturer specifications. Ensure that the air system is charged to 100 psi so that airbag height is correct. The next step is to determine if the front tandem is skewed relative to the steering axle. Using the string line, hook the end of the string onto the tire or other convenient location on the rear side of the front drive axle. Run the string forward to the front wheel at hub height if possible. On vehicles with full aerodynamic skirting packages, the bottom of the hub face is usually the best option. While watching the string and its relationship to the forward sidewall of the front drive axle tire, move the string in toward the wheel or away from the wheel until the string just touches the forward sidewall. At this point, the string will be touching both front and rear sidewalls and now represents a line perpendicular to the axle itself. Measure the distance from the string to the wheel just below the dust cap on the front wheel bearing or the bottom of the wheel hub for trucks with aerodynamic skirts, and record. Move to the opposite side of the vehicle and repeat this procedure. Compare the readings to determine which side is higher and by how much. The side with the highest number indicates that the drive axle is angled to that same direction. For example, if the reading on the left side was 25 millimeters and the reading on the right side was 61 millimeters, then the drive axle is angled to the right side. Differences greater than 25 millimeters indicate excessive axle thrust. After the readings are taken for the string method, go back to the front axle and raise it with the jack so the tires are approximately 1 inch off the ground. Please remember to chock the rear wheels so that the vehicle does not roll off the jack. While the wheels are elevated, check both sides for excessive wheel bearing and kingpin play. If the kingpin has excessive play, the brake chamber will show movement. Each wheel must be marked with a scribe line by first spraying a light area of paint on the center rib while the tire is spinning. After this paint has been applied, carefully scribe a thin line in the paint around the entire circumference of the tire. After this is done for both tires, check to make sure that they are still steered straight ahead by measuring from the wheel flange to the leaf spring on both sides, as was done for the string method. Or check to make sure that chalk reference marks on the steering wheel and column are aligned. Take a large plastic trash bag, heavy-duty type is best, and fold it until it is slightly larger than the tire footprint. Place one bag under each tire and lower the jack. The purpose of the plastic bag is to allow the steer tires to return to their normal operating position after they are lowered. Failure to use the plastic bags or other frictionless surface such as slip plates or turn plates will result in the tire wheel assemblies contacting the ground in an abnormal orientation and will result in incorrect tow readings. With the steer tires on the ground, step onto the vehicle and bounce your weight up and down to ensure that the steer tires have returned to their normal operating position. Measure the distance between the two scribed lines on the rear side of the tires with the tape measure. This measurement must be done at the same height on both sides, and therefore it is helpful to use the paint cans as a reference. Record this number and repeat the measurement at the front of the tires again at the height of the paint cans. The difference between these two measurements represents the static toe-in or toe-out of the steer axle. If the distance is less in the front than the rear, the tires are towed in, and if it is greater in the front, they are towed out. For example, if the reading is 20-32 millimeters in the front and 20-36 millimeters in the rear, then the truck has 4 millimeters of toe-in. Readings outside a range of 0 to 2 millimeters toe-in indicate that corrections are necessary. The Ackerman principle determines the correct steering axle geometry that allows the inside tire to turn on a smaller radius than the outside tire in a turn. This relationship can be measured with proper equipment, but the procedure is beyond the scope of this video. Improper Ackerman can produce a wear pattern which resembles toe-in or toe-out, and is more important to urban service than line haul. Your Michelin representative can assist you with this measurement. Since caster is not normally associated with tire wear, it is only necessary to ensure that a large difference is not present between caster on the left and right side of the steer axle. Ensure that the U-bolts connecting the front axle and springs are tight. Examine the caster shim located between the right spring and axle. Ensure that the shim on the left side of the axle is installed in the same orientation and that they are similar in size. Any vehicle once aligned will stay aligned except for 3 reasons: worn, bent, or broken parts. Identification of worn vehicle components is an integral part of alignment. Failure to identify worn components may result in a truck being aligned properly, but as soon as it leaves the shop, the misalignment condition returns. Some common areas that need to be checked include the following items. Tie rod ends. Tolerances for tie rod ends are 60 thousandths axial play. Drag link. Tolerances for the drag link are 60 thousandths. Kingpin. If the vehicle is properly lubricated, kingpin life is very long. Wheel bearings. Tolerances for the wheel bearings are 0 to 5 thousandths on adjustable wheel bearings. For vehicles with outboard mounted brake drums, cleanliness of the mounting surface or hub boss is critical. Check for signs of excessive wear in the spring perch. Spring shackle pins and bushings should have no play. Spring eye bushings. Check for signs of excessive wear. Don't overlook hidden parts, such as this spring eye and bushing. Check to see if the suspension to frame fasteners are normal bolts or huck bolts. Check for signs of loosening, such as disturbed paint or rust streaks. Suspension pedestal. Look for cracks or signs of loosening. Rear suspension bushings. Look for excessive wear. Check torque arms or panhard rods for excessive wear in bushings. Ensure that U-bolt torque is correct to manufacturer's specifications. Remember that a major step in achieving optimum tire performance is ensuring correct axle alignment, which includes a thorough examination of suspension components. The techniques and tips presented in the Michelin Attack Plus system provide a quick and effective method of getting the most out of your tires.
Michelin, a better way forward.